Hello everyone, welcome to the Internship Studios session on AWS EBS and EFS, which stand for AWS Elastic Block Store and AWS Elastic File System. So in this session, we'll understand the theoretical overview of EBS and EFS, and also we'll be doing the hands-on sessions on how we will create the snapshots and the volumes and how we will take backups and also will perform the EC2 hibernation. So first of all, before moving to the introduction of these concepts, we need to first ask ourselves why we need to learn these concepts. So in the field of cloud engineering and DevOps, so cloud engineering is and DevOps is a booming market nowadays in the IT sector. So learning AWS Elastic Block Store and Elastic File System is very crucial due to their fundamental roles in managing storage solutions in the AWS cloud environment. AWS EBS provides block level storage volumes that can be attached to Amazon EC2 instances. So, as a cloud engineer or DevOps professional, understanding EBS is very essential for efficiently managing and optimizing storage performance for EC2 instances. So EBS volumes offer features such as snapshotting, enabling data backup and recovery, and the ability to create customized storage solutions tailored to your application requirements. So knowledge of EBS is vital for ensuring data persistence, durability, and performance within the EC2 based applications. On the other hand, we have this AWS EFS, which is the Elastic File System. So this is also very fully managed, scalable file storage service that can be easily shared across multiple EC2 instances. In a cloud or DevOps role, mastering EFS is crucial for applications that require shared access to data, such as web servers, content management systems, and development environments. EFS simplifies the process of managing file storage at scale. It also provides a very scalable and elastic solution for applications that demand shared file systems. So in summary, we need to learn AWS EBS and EFS since these are essential for the future cloud and DevOps engineers, as it empowers them to design, deploy, and manage scalable and reliable storage solutions for applications running on AWS. So this knowledge will ensure the efficient utilization of storage resources, which enables data durability and also supports the seamless scaling of applications in a cloud environment. So the mastery of EBS and EFS contributes to the overall effectiveness and resilience of cloud-based systems, aligning with the core responsibilities of cloud and DevOps professionals. So I'm very confident that these sessions will really be a good cover of the basics as well as the hands-on session. So coming to the first slide, we first will have an overview of the high level overview of the AWS storage services that we have. So firstly we have the Amazon Simple Storage Service, which is popularly known as Amazon S3. So it is a service that provides scalable and highly durable object storage in the cloud. So we already saw this in our S3 session and also had a hands-on session as well. So this is the primary and most popular service when it comes to the object storage aspect in AWS. Coming to the same one, which has the Amazon Glacier. So it's a service that provides low cost, highly durable archive storage in the cloud. So also we saw about the Amazon Glacier concept in the Amazon S3 session. So the next two storages what we'll be covering in the today's session. The primary one is the Amazon Elastic File System, in short called as EFS. So it's a service that provides scalable network file storage for Amazon EC2 instances. By scalable network file storage, we are referring to a storage solution that can effectively and efficiently grow or shrink in capacity and performance to accommodate the changing needs of an organization's data storage requirements. So, in the context of cloud computing and distributed systems, scalability is a very critical aspect. So, we need to ensure that a file storage system can handle increased demands seamlessly without sacrificing performance or reliability. Also, the key characteristics of a generic scalable network file storage will include the capacity scaling, the performance scaling, the elasticity aspect, the load balancing, the fault tolerance, and the global accessibility. So, scalable networks file storage is particularly relevant in the cloud environments and for applications with varying and unpredictable workloads. Technologies like network attached storage, which we in short call as NAS, and distributed file systems such as AWS EFS, or in case we may take example of the Google Cloud Storage. So these are very nicely designed with scalability in the mind to meet the evolving storage needs of modern and dynamic IT infrastructures. So we'll be going in depth in our coming session. And next is the Amazon Elastic Block Store. So it's a simple service that provides block storage volumes for Amazon EC2 instances. Here you may have a question, what is a temporary block storage volume? So in generic terms, a temporary block storage volume, it refers to a type of storage resource that is designed for short-term and non-persistent use. This type of storage is actually typically used in the cloud computing environments and is associated with virtual machines or instances. So in the AWS perspective, this is associated with the EC2 instance, which is the name given for the virtual machines. So they have these very good characteristics of having these temporary block storage volumes. So the primary one is in their name itself, which is non-persistence. So temporary block storage is not intended for the long-term data storage. So you will not use them for the longer duration. Like if you want to use them for many years, you can't for many months you can't use this type of storage. So any data stored on these volumes is typically ephemeral. Ephemeral means temporary, and it is expected to be transient. When an instance is terminated or stopped, the data on the temporary block storage volume is usually lost. So another one is fast and local storage. So what this temporary block storage volumes do is they are provisioned on a high speed local storage devices that are physically attached to the host machine running the virtual instance. So this design usually ensures fast read and write operations, making temporary storage suitable for tasks that require high input output performance. This is also instance specific, like it is directly attached to the virtual machine and its life cycle is very closely linked to the life cycle of that instance. So the moment you start the virtual machine, a temporary block storage is attached, and when you terminate the machine, automatically that storage will get deleted. And the common use cases are they are temporarily used for this caching and scratch page in applications where data persistence is not critical. For example, temporary files generated during computation, caching of frequently accessed data, or other short-term storage needs may utilize temporary block storage. Another good thing is these are cost effective. So since temporary block storage is often designed for short-term use and is not persistent, it is generally more cost effective than long-term persistent storage options. So users will be billed for the storage capacity provisioned during the runtime of the virtual machine. So this is about the EBS. So we also have the Amazon EC2 instance storage. So this is also temporary block storage volumes for Amazon EC2 instances. So we have other storage options as well. We have the AWS storage gateway, which is an on-premise storage appliance that integrates with the cloud storage. And we also have the AWS Snowball. It is a service that transports the large amounts of data to and from the cloud. So AWS has this Snow family of services. We have that Snowmobile, which is actually a truck, big truck, which is used to perform on the site data related operations. And we also have a lot of other services. So you can go to the of online website and search AWS Snow family of services, and you will have a hell lot of services actually. So we also have Amazon CloudFront. So it is a service that provides a global content delivery network. Amazon has designed this to enhance the delivery of the web content usually. So CloudFront accelerates the distribution of static and dynamic content, including images, videos, and APIs to users globally. So by caching content at edge locations strategically positioned around the world, CloudFront reduces latency and improves the overall performance of enterprise websites and applications. So users can take advantage of this service since CloudFront also integrates with most AWS services as well, such as Amazon S3, Amazon EC2, or any other like popular services to ensure the efficient content delivery. So the service automatically scales to handle varying traffic loads, providing low latency access to content while optimizing costs through pay as you go pricing. So in the backend, CloudFront employs SSL or TLS encryption to secure data in transit, and also it offers features like custom SSL certificates and access controls for enhanced security. Additionally, it provides real-time monitoring and analytics through AWS CloudWatch, enabling users to gain insights into content delivery performance. So overall, AWS CloudFront is a scalable, secure, and globally distributed CDN solution that contributes to improved website and application responsiveness for end users across the globe. So this was an overview of the AWS storage services, but here we'll be focusing on the AWS EFS and EBS in particular since they are the agenda of our session today. First, we'll come to the introduction. Uh, this is the generic definition of the Amazon Elastic Block Store. So it says Amazon EBS is an easy to use, scalable, high performance block storage service designed for the Amazon Elastic Compute Cloud. It enables EC2 instances to persistently store data even after the instances are terminated, offering scalable and high performance block storage volumes. So we'll understand this by using of a scenario. So let's break down the concept of a hard drive in a way that's easy to understand. So you may have heard of the hard drives. So hard drive is like the memory bank of your computer. So imagine it has a vast organized library where you can store and retrieve information whenever you need it. So when you save a document, install a game or download a movie, you are essentially putting that data in your computer's hard drive for your safety purpose. Now think of this hard drive as a collection of small lockers or storage units. So each unit can store a certain amount of data and you can organize your information by placing related items in the same locker. So these lockers in the computer world are called sectors and they work together to form the entire hard drive. The information stored on a hard drive is persistent, meaning that it stays there even when the computer is turned off. For example, if you have your personal computer and you download a movie and share it to a folder in a C or a E drive in terms of the Windows machine. So when you switch off the computer and turn it on the next day morning, you still see that the movie collection is still existing in your personal computer. So is meant by it is meant by that the data is persist in your computer. So this is why your documents, pictures and applications are still available the next time you power up your computer. This is meant by the persistable storage type. So let's connect it to our EBS. So in the digital era of cloud computing, we have these computers and servers which exist virtually. So we don't have access to them the physically. We are just interacting them with the APIs using our browser. But we still need a way to store and retrieve the data. So this is where EBS comes into play. So think of EBS similarly as a virtual hard drive in the cloud. So it's a digital counterpart to the physical hard drive in your physical computer you have with you. So just like your computer's hard drive, EBS also provides storage units or blocks you can say that you can attach to your virtual servers in the Amazon's cloud, which are known as EC2 instances. So these blocks act as the persistent storage for your virtual machines. So each EBS volume is like a separate digital hard drive that you can connect to your virtual server, allowing you to organize and store data just like you would on your local computer. So the analogy also continues with different types of EBS volumes. So each is optimized for a specific task. We have different types of hard drives. So similarly in the cloud also we have the different type of hard drives. We have the general purpose SSD, which is solid state drive EBS volumes, who are like the high performance storage you would use for everyday computing tasks, while the provisioned IOPS SSD volumes are more like a high speed, high capacity drive you might use for video editing or other data intensive applications. So just as you might take a backup of your computer's hard drive to protect against data loss, in this case EBS allows you to create snapshots. So we'll see what snapshots are and we'll also see how to create a snapshot in the hands-on session. So these snapshots are essentially copies. So snapshot is just like a photograph. You click the photograph, right? It's called as a snapshot. So you'll take the copy of the storage which is available at that particular time using the snapshot technique in the cloud console. So these snapshots are essentially copies of your EBS volumes at a specific point in time, so which serve as the backup. So in future if you want to take that copy, so you can also take using the snapshot to restore the data or create new volumes. So to conclude, it's a hard drive. It's just like a hard drive which is the memory bank of our computer, and in the cloud AWS EBS serves a similar purpose by providing virtual, scalable, and persistent storage for the digital assets. So we need to understand this connection, which will help us to design and manage storage solutions in the cloud. So this is the logo of the Amazon EBS. So hope you had a good understanding of the definition and had an overview. So we'll see this high level architecture given by the AWS. It's the flow of how EBS works. So firstly we have this elastic block, Amazon elastic block store option. So there are two types of storage options. One is the SSD based storage option and another one is the HDD based. So we have this SSD based, which refers to AWS EBS volumes that use the solid state drive technology for storage. So you may have heard of computers nowadays coming with 256 GB SSD, 512 GB SSD. So these are bit costlier than the HDD storage classes we have. Like compared to the HDD equivalent laptops, SSD laptops are comparatively costlier. So why this is because SSDs are a type of non-volatile storage device that stores data persistently and is known for the faster performance compared to traditional hard disk drives. So in the context of EBS here, using SSDs as the underlying storage medium enhances the speed, I/O performance and overall responsiveness of the storage solution. So we have two categories here, which is the general purpose SSD and we have the provisioned IOPS SSD here. So the general purpose SSD is the default EBS volume type for the SSD based storage. So it is designed to deliver a balanced mix of price and performance for a wide variety of workloads. General purpose SSD volumes are most suitable for applications providing low latency performance and the ability to burst IO up to 3000 IOPS, which is input output operations per second per volume. In the next type we have here the provisioned IOPS SSD. So for applications that require higher and more consistent IO performance, such as databases with heavy read-write workloads, Amazon provides the provisioned IOPS SSD volume type. With provisioned IOPS, you can specify the amount of IOPS you need for your volume. So it is up to 64,000 IOPS per volume. So this allows you to tailor the performance of the storage to meet the specific requirements of your application. So you may have confusion what is IOPS is. So IOPS is like 4-letter word IOPS or input output operations per second. So it is a metric that is used to measure the performance of the storage devices. So they indicate how quickly they can read or write data. So to understand IOPS in the simpler terms, let's use an analogy here and break down the concept. So you can imagine a very busy kitchen, like a restaurant kitchen. So think of IOPS like the activity in a busy kitchen. So in a kitchen, there are various tasks happening simultaneously. Like there will be someone chopping the vegetables, there will be someone who is the boiling the water, and someone who will be cooking on the stove. So each of these tasks represents an input or output operation. So now let's relate this to computing. So IOPS in computing. So in the world of computers and storage, IOPS measures how many input or output operations a storage device like a hard drive or SSD can handle in 1 second. So these operations include tasks such as reading data from the storage or writing data to it. The busy kitchen is like your storage device here. So it can be a hard drive or an SSD. So just as a kitchen handles multiple tasks simultaneously, a storage device also processes various read and write operations. The tasks you can relate to as the input or output operations. So each task in the kitchen, it may be chopping, boiling, or cooking, it represents an input or output operation. Similarly, in computing, an input operation could be reading your data, and an output operation could be writing your data. So IOPS here is the cook's efficiency. So the speed at which the cook completes the tasks reflects the IOPS of the kitchen. So if the cook can chop vegetables quickly, boil water fast, and multitask efficiently, the kitchen has a very high IOPS. So in computing terms, a storage device with high IOPS can handle a lot of read and write operations in a very short amount of time. So coming to a real world application, so let's relate this to a real world scenario. Imagine you are running a video editing application on your computer. So we have lots of video editing like DaVinci or like any application that you take. For example, in mobile also we have some InShot editors. So it's a similar editor for the computers as well. We have ProRes from Apple. So when you are editing a video, the applications needs to quickly access and modify various parts of the video file. So this involves a lot of read and write operations on your storage device. So if your storage device has high IOPS, it can keep up with the demands of the video editing application, allowing for very smooth and responsive editing. On the other hand, a storage device with lower IOPS might struggle to handle. So you may have these hanging issues due to the numerous read and write requests. So it leads to the slower performance and potential delay in your editing process. So in conclusion, IOPS is a critical measure of how fast a storage device can handle the tasks of reading and writing the data. High IOPS indicate that the storage device is efficient and it can manage a large number of operations per second, making it well suited for applications that require quick access to data like databases, video editing, or any task involving frequent data interactions. Understanding IOPS helps in choosing the right storage solution for specific computing needs, ensuring optimal performance for various applications. So, at a high level understanding, I think you have understood the concept of IOPS here. So, similarly, we have the HDD based. You may already be familiar with HDD since some of you, if are having laptops like which are coming in the affordable category, mostly are based on hard disk drive. So it's the place where the computer stores all its files from the operating system that makes your computer run to the pictures, videos, and documents you save. So think of your computer's HDD also like a reliable but slightly slower library. So when you want to have a specific book, for example, in the analogy of a library, I'm saying the specific book can relate to a file, and you have a librarian which can relate to it for as a computer. So it has to go to the shelf. The shelf here in our case is the HDD to find the book. Book in our case is the related data and bring it to you. So you means the screen here, the display screen we have on the laptop. So this process is effective, but it takes a little more time than if the books were instantly available on a open table. So open table means we have this SSD which has this advanced storage options. There are some pros and cons as well. So HDDs are cost effective. They provide a lot of storage space. So you can see that cheaper laptops for around 20 or 30,000 they come with 1 TB HDD. So if you want a 512 GB SSD, so you need to spend around 40 or above, like above 40,000 rupees INR. So these are only good for storing large amounts of data like your photo collection or a big music library, you can say. But HDD have moving parts inside them, so they are generally slower than the newer technologies like SSDs. So this can lead to longer load times for applications and files. So we have these two storage based options in the cloud. So the next steps are very simple. So you can attach based on the selected type of storage. We can attach to the EC2 instance. EC2 instance is a virtual server in the AWS. So it says select your volume type here. Select the right volume type based on your application's needs and costs, and again attach to your Amazon EC2 instance. Uh, it says attach your new Amazon EBS volumes to either new or existing EC2 instances. So we can attach it to a newly created one while the process of creating the new instance, or if you have created the EC2 instance before and it is already existing, from the externally you can attach a EBS volume as well. So it says multi attach support. It is supported for the Linux on the AWS Nitro system. So we can enable the multi attach also here, and then we can run your application. So we can run our applications after attaching the persistent block volumes that offer 99.999% availability. So here in this context we can say that a 99.999% availability, it is offered referred to as 5 nines, because we have 5 times 9 here. So when it is applied to the AWS EBS, it means that the service is designed to be available and accessible for use 99.999% of the time over a given period, typically measured on an annual basis by the AWS. So there is a bit of downtime here with 99.999% availability here. The service allows for only approximately 5.26 minutes of downtime per year. So you means if you are using Amazon EBS, you have in a year, you can say in a non-leap year we have 365 days, right? So in 365 days, you only have the system down for 5.26 minutes, or around 5.5 minutes, 5 minutes 30 seconds. That's a very good support by AWS, because in a year it's just a 5 minutes. So this is a very extremely small window of time that we have during which the service might not be available. So achieving such high availability requires robust infrastructure also. So AWS is implementing their multiple measures such as distributing data across the availability zones to ensure that even if one part of the infrastructure experience issues, there are redundant systems in place. So this is a very good availability for a service. So coming to the next one, we have the key features of EBS. So initially we have the block storage. So Amazon EBS provides block storage, meaning it allows users to create volumes that function as raw unformatted block devices. These volumes can be attached to EC2 instances, appearing as a block devices that can be formatted with a file system of choice. So block storage, you can imagine like it's a digital version of a storage unit or a box where you can put things. Imagine it has a collection of individual boxes, and each box can hold a specific amount of data. So these boxes are called blocks. So in modern computing, block storage is a method of storing data in fixed size blocks, and each block has a unique address. Each block can store a piece of information such as a document, image, or a part of a file. So the unique addresses help the computer keep track of where each block is located, making it easy to find and retrieve the stored data. Here's a simple breakdown, like block storage is commonly used in scenarios where data needs to be accessed and modified at the level of individual pieces. For example, it's like having a set of labeled boxes in a warehouse where you can add, remove, or rearrange items independently in each box without affecting others. So this flexibility makes block storage well suited for tasks like running databases, virtual machines, or any application where data changes frequently and needs to be accessed randomly. So the next key feature is the persistence. So EBS volumes persist independently of the life cycle of an EC2 instance. So even if an EC2 instance is stopped or terminated, the data stored on the EBS volume remains intact. For example, if you spin up an EC2 instance and while it is run while you have attached the EBS volume when you had created the EC2 instance and you stop that instance, you will not lose any data that you may have stored on that EBS volume. Or in case if you also terminate the instance, like if you permanently want to get rid of that instance, then you can uh, after the EC2 is terminated or deleted also, the EBS volume remains intact. So all the data that you have performed, like any specific data related ops, that will stay on the EBS volume. Next is the volume types. So Amazon EBS offers different volume types optimized for various use cases. So these include general purpose SSD, which is saw in the previous architecture diagram, the provisioned IOPS type SSD. These are the two types of SSD options. We also have throughput optimized HDD and cold HDD. We'll deep dive like what this throughput optimized and cold HDD are in the further slides. So each type has specific performance characteristics and pricing accordingly. So like all these four types volumes are designed for the specific use cases and each comes with its own pricing. So coming to the snapshots, another it's a very important feature in the EBS. So users can create point in time snapshots of EBS volumes. So capturing the volume's entire state including data configuration and encryption settings. Snapshots are incremental and users can use them to create new volumes or migrate data to different regions. So we'll discuss snapshots in a beautiful way here by taking an analogy. So let's use photography. So I think most of you would be familiar with the photography. So you can think EBS snapshot has a photograph of your digital storage, much like taking a picture with a camera. So the initial thing what we will do there is the capturing a moment. So it's like a data at a point in time. So just as a photograph captures a specific moment, an EBS snapshot captures the state of your digital storage at a particular point in time. So it freezes everything on your storage just like you save a moment in a picture. So another thing is the backup copy we have. So like you mean by creating copies. So imagine you take a copy of a photograph so that even if the original gets damaged, you have a duplicate. Similarly, an EBS snapshot is a copy of your digital storage. So if something goes wrong with your data, you can go back to the snapshot, a bit like having a spare photograph. So another thing is changing colors. So if you take a series of photographs but only change a few colors in each shot, you save space by saying these colors are the same, just note the changes. So EBS snapshots also work similarly. They save only the changes that happen to your storage over time. Also, it's like creating copies for friends. Imagine you want to share a beautiful photograph with your friends. So instead of taking the same photo over and over, you make copies to share. With EBS snapshots, you can create new digital storage or volumes based on the snapshot, just like making multiple copies of a picture to share with different people. We have data recovery options, which is helpful in restoring the moment. So if your photography gets damaged or altered, having a backup copy allows you to restore it to the way it looked in the original moment. Similarly, if your data in the EBS volume is accidentally changed or deleted, you can use a snapshot to restore it to how it was when the snapshot was taken. So it's like moving pictures to a new album. So it also supports the cross region migration. So if you decide to move your photo collection to a new album in a different room, you can take your pictures with you. So similarly, the EBS snapshots allow you to move your digital storage and data to a different region in AWS. So in essence, an EBS snapshot is like taking a snapshot of your digital storage, freezing it in time, and having the ability to create backups, restore, or even share your data easily, much like managing a collection of photographs. So hope you had an idea of what snapshot really is. So coming to the next feature, which is encryption. So EBS volumes can be encrypted using the AWS key management service. So encryption provides an additional layer of security for sensitive data stored on EBS volumes. So next is the performance. Depending on the volume types, EBS volumes offer different levels of performance. Provisioned IOPS volumes, for example, provide consistent and predictable performance based on the provision input-output operations per second. Actually, you need to understand the specific needs of your application while selecting the appropriate EBS volume type and configuration, because they are the key to achieving the optimal performance in AWS. So we have lots of, so here is one provisioned IOPS volume they have given example. So it provides a very consistent predictable. So if you have some very predictable workloads as part of the application, you can make use of the provisioned IOPS volumes. So next one is the attachment to EC2 instances. So EBS volumes can be attached to EC2 instances in the same availability zone. So volumes can be detached from one EC2 instance and attached to another, providing flexibility and scalability. So this is very straightforward. So it supports a very flexible operations with respect to attaching it to the EC2 instances. But here you can note that it is supported for the same availability zone. So coming to the next one, which is the elastic volumes. So Amazon EBS supports elastic volumes, allowing users to dynamically increase volume size, adjust performance, and change the volume type without detaching it from EC2 instance. So meanwhile, like without detaching it only, you can manually scale it up, like the volume size, and you can adjust the performance. So it is a very good feature. So next are the use cases. So EBS volumes are suitable for variety of use cases, including databases, file systems, application data, and boot volumes for EC2 instances. The choice of volume type depends on the specific requirements of the workload. So we have already discussed there are around 4 or 5 types of EBS volumes. So also it supports the multi-attach. So certain EBS volume types support multi-attach, allowing a volume to be attached to multiple EC2 instances simultaneously. So this is useful for scenarios like clustered databases that require shared storage. So if you have an application which needs to uh, have a cluster type of database system, then with the help of EBS volume multi-attach, you can also use this facility. It also has integration with EC2 features. So EBS seamlessly integrates with various EC2 features such as AMI, Amazon Machine Images, instance store backed instances, and auto scaling groups, providing storage solutions for a wide variety of applications. So it has a good integration with the EC2 features. So coming to the EBS volume types. So Amazon EBS provides multiple volume types that allow you to optimize storage performance and cost for a broad range of applications. So these volumes are divided into two major categories: SSD backed storage for transactional workloads such as databases, virtual desktops and boot volumes, and HDD backed storage for throughput intensive workloads such as map reduce and log processing. Uh, Here SSD based volumes include the highest performance EBS volumes, which are IoT Block Express and IO1, for your most demanding transactional applications including SAP HANA, Microsoft SQL Server and IBM DB2, and general purpose SSD volumes, which are GP3 and GP2, that balance price and performance for transactional applications including virtual desktops, test and development environments, and interactive gaming applications. So we have HDD based volumes, which include throughput optimized HDD, which come in the name of ST1 for frequently accessed throughput intensive workloads, and the lowest cost cold HDD, in short SC1, for less frequently accessed data. So having the knowledge of EBS volume types is very important for the examination point of view and the certification type point of view. So if you are planning to attend the AWS Solution Architect Associate or database related or data related specialty in AWS, so it's very handy that you need to have the info of the different volume types available in the AWS. So it is also helpful in the future career, like while discussing with clients, if they have some varying application requirements and which types of uh, EBS volumes they may need to use, then you would have a greater say when you have the clear cut understanding of which volume is used for what application. So at first we'll discuss the SSD based volumes. So the first one we have here is the Amazon EBS IO2 Block Express. So it says it offers the highest performance block storage in the cloud with 4 into higher throughput IOPS and capacity than GP3 volumes, along with sub-millisecond latency. So Block Express is the latest generation of Amazon EBS storage server architecture, purpose built to meet the performance and latency requirements of the most demanding applications. So IO2 Block Express is designed to provide 4000 MB per second throughput per volume, 256,000 IOPS per volume, up to 64 TIB storage capacity and 1000 IOPS per GB, as well as 99.99% durability, making it ideal for the largest, most IO intensive mission critical deployments of Oracle, SAP HANA, Microsoft SQL Server and SAS Analytics. So actually in the past what used to happen was customers had to stripe multiple volumes together in order to go beyond single volume performance. But today IoT volumes can meet the needs of the mission critical performance intensive applications. Sorry. But this AWS has designed a very newly built architecture that delivers the highest levels of performance with the sub millisecond. So it's a very low latency by communicating with an AWS Nitro based system instance using the scalable reliable datagrams protocol, in short, which is the SRD protocol, which is implemented in the Nitro card dedicated for EBS IO function on the host hardware for the instance. So Block Express also offers the modular software and hardware building blocks that can be assembled in many ways. So giving you the flexibility to design and deliver improved performance and new features at a faster rate. So we'll quickly see the uh, good features that we have. The first thing is it's the EBS provisioned IOPS SSD IO2 Block Express volume type. So description is high performance SSD volume designed for business critical latency sensitive applications. So latency mostly involves the streaming related applications. So if you are hosting live events like cricket matches in India, we have, right? So we have the T20 matches or any one day related matches. So the user, for example, if you are using a mobile, so the latency is the time between the live event happening and the time it has been streaming. So it should be very minimal, like millisecond. The live action should be always like up to the correct time of event. So if it's happening at 3 p.m. 3:30 p.m., it should be as it is being shown in the streaming app as that relevant activity itself. So this is about the latency. So if there are some media streaming applications who have very sensitive latency related issues, then they can leverage this. So use cases are IO intensive, NoSQL and relational databases. So it has the API name of IO2. So volume size available is 4 GB to 64 TB. Durability is 99.999%, which has the good SLA of 5. We have only downtime of 5 minutes around per year. So the latency is also sub millisecond, which is very like one of the industry leading ones. So max IOPS per volume is 2,56,000. So max throughput is the throughput per volume is 4000 MB per second. We have the max IOPS per instance is equal to 4 lakhs. So max IOPS per GB is equal to 1000 IOPS per GB. So max throughput per instance is equal to 12,500 MB per second. So you may have question what throughput is. So in simple terms, throughput in the context of AWS EBS refers to how fast data can be read from or returned to your storage. It's like measuring the speed at which information travels between your computer and the storage service in the cloud. So you can imagine a highway. So think of throughput as a highway between your computer, so in our case Amazon EC2 instance, and your storage, which is the EBS volume. So the number of lanes on this highway represents the throughput, determining how much data can travel back and forth at any given time. So if you have high throughput, it means it has a wide highway. So a high throughput means you have a wide highway with multiple lanes. Imagine it like a six lane expressway. So this allows a lot of data to flow quickly between your computer and the storage, like having a super highway where many cars can travel simultaneously on that highway. So low throughput means it's a very narrow road. So on the other hand, low throughput is like having a narrow path or a single lane road. It slows down the flow of data, similar to having fewer cars able to move at once on a smaller road. This is about the throughput related aspect. So accordingly, the prices we have $0.125 per GB for a month. Uh, we have like there are some cumulative different costs. The price is $0.065 per provisioned IOPS month up to 30,000 IOPS. So we have cumulative from 32,000 to 64,000. We have $0.046. And next, greater than 64,000 IOPS, we have 0.032. So the more they use, the more the IOPS perform like operations you perform, the less is the price. Also, the dominant performance attribute is IOPS, throughput, latency, capacity, and volume durability. So these are the main considerations that you have to take before selecting this volume type. So next one is the Amazon EBS IO1 type. So it is backed by a solid state drives and is a high performance EBS storage option designed for critical IO intensive database and application workloads, as well as throughput intensive database and data warehouse workloads such as HBase, Vertica and Cassandra. These volumes are ideal for both IOPS intensive and throughput intensive workloads that require low latency and have moderate durability requirements or include but built-in application redundancy. So IO1 is designed to deliver a consistent baseline performance of up to 50 IOPS per GB to a maximum of 64,000 IOPS and provide up to 1000 MB per second of throughput per volume. To maximize the benefit of IO1, we recommend using EBS optimized EC2 instances. So when attached to EBS optimized EC2 instances, IO1 is designed to achieve a single digit millisecond latencies and is designed to deliver the provision performance 99.9% of the time. So this is also similar to the previous type of volume. It supports IO intensive and application workloads which are throughput intensive. So coming to the features, the volume type is EBS provisioned IOPS SSD IO1. So it is also a high performance SSD volume designed for latency sensitive transactional workloads. Accordingly, we have the use cases which is for IO intensive NoSQL and relational databases. The API name is IO1. So volume size is available from 4 GB to 16 terabytes. Durability is also fairly good from 99.8% to 99.9%. So we have max IOPS per volume is equal to 64,000, and these are the related max throughput per volume is 1000 MB per second, max IOPS per instance is 4 lakhs, and we have this good max IOPS per GB score which is 50 IOPS per GB. Max throughput per instance is equal to 12,500 MB per second. Here also we have a good latency which is single digit millisecond. So the price is $0.125 per GB month plus 0.065 per provision IOPS per month. So dominant performance attribute is the IOPS here. So mostly IOPS, if you have intensive operations, then you can take care of this. Like you can select this type of the volume. So next is the Amazon GP3 volumes. So these are also the latest generation of general purpose SSD based volumes that enable customers to provision performance independent of storage capacity while providing up to 20% lower pricing per GB than existing GP2 volumes. So the new GP3 volumes deliver a baseline performance of 3000 IOPS and 125 MIBPS at any volume size. Customers looking for higher performance can scale up to 16,000 IOPS and 1000 MIBPS for an additional fee. The GP3 volumes are designed to offer single digit millisecond latency while delivering the provision performance 99% of the time, making them ideal for a wide variety of applications that require high performance at lower cost, including virtual desktops, medium sized single instance databases such as Microsoft SQL Server, Cassandra, MySQL, Oracle DB, Hadoop Analytics clusters, low latency interactive apps, dev and test, and boot volume. So if you need a greater number of IOPS, then GP3 can provide. AWS recommend that you use IO2 block express volumes. To maximize the performance of GP3, AWS recommend using EBS optimized EC2 instances. So if you are looking cost as one of the factor, so Amazon GP3 is a very good SSD based EBS volume as well. So coming to its features, it's also EBC general purpose SSD. So it balances price performance for a wide variety of transactional workloads. So use cases are virtual desktops, medium sized single instance databases such as MSFT SQL Server and Oracle DB, low latency interactive applications, dev and test environments. We can use this, and for boot volume. So if you are using this for server booting purposes, then you can use this volume type. We have GP3 as the API name. We have this volume size varying from 1 GB to 16 TB. Durability is fairly good at 99.8 to 99.9%. So these are the respective these actually hard coded values will not be asked in the examination point of view, but it's actually a good practice to know, like at least in what range the IOPS it is performing for our load testing purposes. So we have max IOPS per instance is equal to 2,60,000, which is good. So it also has a single digit millisecond. The storage price is 0.08 per GB for a month, which is fairly good compared to other types of storage. Provision performance price also we have 3000 IOPS are free at first and 0.005 per provisioned IOPS month. Over 3000 IOPS we have 125 MB per second free and $0.04 provisioned MBs month over 125 MIBPS. So dominant performance attribute also is dollar per IOPS here. So next is the Amazon EBS GP2 volumes. So these are also one of the SSD type of volumes from AWS. These are suitable for a broad range of transactional workloads, including DevOps test environments, low latency interactive applications, and boot volumes. GP2 is designed to offer single-digit millisecond latency, deliver a consistent baseline performance of 3 IOPS per GB to a maximum of 16,000 IOPS and provide up to 250 MB per second of throughput per volume. So GPT volumes smaller than 1 TB can also burst up to 3000 IOPS. IO operations are included in the price of GP2. So you only pay for each GB of storage you provision. So this is a good pay as you go model. So GP2 is designed to deliver the provision performance 99% of the time, which is fairly good actually. There's a 1% of durability issue. So if you need a greater number of IOPS than GP2 can provide, such as a workload where low latency is critical, or you need better performance consistency, we recommend the AWS recommends using a IO2 block express. So to maximize the performance of GP2, AWS recommends using EBS optimized EC2 instances. Coming to the features, the volume type is EBS general purpose SSD again. So it's suitable for balanced operations, which involves price as a factor for a wide variety of transactional workloads. It also suitable for boot volumes, low latency interactive apps, dev and test environments. The API name is GP2. Volume size varies from 1 GB to 16 TB. Durability is also similar to the previous two. It is about 99.8% to 99.9%. Max IOPS per volume is 16,000. So we have this fairly good number of max IOPS of per instance is 2,60,000. The latency is again single digit millisecond. The price is fairly priced at 0.10 per GB month. So dominant performance attribute is also here IOPS. So next we have the HDD based volumes. So HDD means the hard disk drives based volume. So as the first option as per the AWS HDD based volumes, we have the Amazon EBS ST1, which is backed by hard disk drives, and it is ideal for frequently accessed throughput intensive workloads with large datasets and large IO sizes such as MapReduce, Kafka, log processing, data warehouse, and ETL workloads. So these volumes deliver performance measured in MB per second of throughput and include the ability to burst up to 250 MB per second per TB. With a baseline throughput of 40 MB per second per TB and a maximum throughput of 500 MB per second per volume, the ST1 volume type is designed to deliver the expected throughput performance 99% of the time and has enough IO credits to support a full volume scan at the burst rate. To maximize the performance of ST1, AWS recommend using optimized EBS optimized EC2 instances. So coming to the features, we have this volume type as throughput optimized HDD ST1. It's suitable for low cost HDD volume designed for frequently accessed throughput intensive workloads. We have use cases for big data, data warehouses, log processing. API name is the ST1. Volume size is available from 125 GB to 16 TB again. So durability is fairly good at 99.8% to 99.9% durability. So max IOPS per volume is 500. Max throughput per volume is 500 MB per second. Max throughput per instance is equal to 12,500 MB per second. So you can see that the IOPS and the throughput is significantly lower than the SDD offerings that AWS has. because that is prone in the pricing. So these are fairly cheaper at $0.045 per GB month. The dominant performance attribute is the MB per second here. So that was about the HDD volume type. So now we are finished with the theoretical concepts of the EBS. Now we are getting introduced to the AWS EFS service. So coming to the definition of EFS, Amazon Elastic File System automatically grows and shrinks as you add and remove files with no need of management or provisioning. So it's a use case of like the working concept of how EFS is designed. So coming to the definition, Amazon Elastic File System is a scalable and fully managed file storage service provided by Amazon Web Services. It is designed to provide scalable shared file storage for use with Amazon EC2 instances and is suitable for a variety of use cases including content repositories, development environments, data sharing, and applications that require shared access to files. So let's use a simpler analogy here to understand the EFS better. So we'll take a refrigerator or a fridge, we can say. So imagine EFS has a shared refrigerator in an office kitchen where everyone can store and access their favorite snacks. So here the EFS at the higher level is the refrigerator. So think of the refrigerator as EFS storage. It's a shared space in the cloud where everyone in the office can keep their food. For example, the food here is the data. So inside the refrigerator, we have shelves for different teams. Shelves are file systems. So inside this refrigerator, there are different shelves, and each shelf is like a file system in EFS. So each team in the office gets their own shelf to organize and store their snacks. So there would be containers on the shelf, so we can relate them to as directories. So on each shelf there are containers, and these containers are like directories or folders in EFS. So they help keep things organized. For example, the marketing team's shelf has a container for campaigning ideas, and the sales team shelf has a container for customer contacts. And inside the container we can have snacks. So snacks in our case will be files. So inside each container there are snacks, and these snacks are like files in EFS. So each employee can add their favorite snacks in bracket files to the containers on their team shelf. We also have the provision of sharing snacks, which means sharing the access here. The cool thing is that everyone in the office can see and share the snacks. Similarly, in EFS, multiple users or applications can access and share the same data, just like employees sharing the office refrigerator. So there's also the provision for easy access, that is good availability. So employees can easily open the refrigerator door and grab their snacks. Similarly, EFS is readily accessible from multiple instances or servers in the AWS cloud. So there would be more shelves for more teams, which also means scalability. So if the office hires more teams, for example, this year they have 500 employees. So next year they may hire 100 more employees. They would be needing more shelves in the refrigerator, right? So the refrigerator can have more shelves added. Likewise, EFS is also scalable, allowing to increase the storage space as your data needs grow. So this is about a simple analogy about the AWS EFS. Coming to how EFS works. So firstly, we have to create the file system using the EC2 launch instance wizard or EFS console or CLI. We can choose any types of methods. Then we can mount our EFS to any of the supported services. For example, any server, we have the serverless offering AWS Lambda, or EKS, Elastic Kubernetes Service, or Elastic Container Service, or Fargate, which are managed services. So the primary one we have EC2. So for example, in our case, we will decide it has a EC2. We can mount the file system to the EC2. Then we can test and optimize the performance for the workloads, whether it suits the relevant service. Then we can move data to our file system from cloud or on-premises sources using AWS Data Sync or SFTP, FTPS or FTP protocols using AWS Transfer Assembly. And then we can share and further protect the file data. So we can optimize cost with EFS lifecycle management and further protect data with AWS backup and EFS replication. So for example, let's take the idea of attaching working this service with the EC2. So we'll start by creating an EFS file system there. So that becomes our virtual storage space in the cloud, similar to a digital file cabinet. Then we can mount EFS to EC2 instances. So each EC2 instance that needs access to the shared file system can mount it, essentially connecting to the EFS file system as if it's an additional drive. It's like just plugging in a shared USB drive that all the instances can use. So enabling shared access. So once mounted, all EC2 instances connected to the EFS file system can read from and write to the same set of files and directories. It's like multiple computers in an office sharing access to the same set of documents stored on a shared network drive. So actually in summary, Amazon EFS provides a scalable and shared file system in the cloud, allowing multiple EC2 instances to collaboratively access and modify the same set of files. It simplifies management of the shared storage for applications that require shared access to data across multiple instances in a scalable and reliable manner. So this is a high level overview of how EFS works. So coming to the key features of AWS. So EFS is designed to provide serverless, fully elastic file storage that lets you share file data without provisioning or managing storage capacity and performance. It can be used with AWS services and on-premise resources, and it's built to scale to petabytes on demand without disrupting application. So serverless in the in terms of like understanding it, serverless is like it's a managed service. So in the backend, it's running on a server, but it's being managed by the AWS in the backend. So you need not take the operational overhead of mounting it on a server. So it's fully elastic means it we can play around with based on the capacity needs. It can be uh, configured with the low storage demands as well as high storage demands. Also it has the ability to scale petabytes. So Amazon EFS is also well suited to support a broad spectrum of use cases from home directories to business critical applications. Use cases include storage for containerized and serverless applications, big data analytics, web serving and content management, application development and testing, media and entertainment workflows, and database backups. You can see that it is supported to a wide variety of use cases here. So the another feature is fully managed. So Amazon EFS is a fully managed service providing network file sharing, shared file system storage for Linux workloads. So Amazon EFS makes it quick and efficient to create and configure file systems. You need not worry about managing file servers or storage, updating hardware, configuring software, or performing backups. In seconds, you can create a fully managed file system using the AWS Management Console, AWS CLI, or an SDK. So one good thing is it's fully managed. So it's being managed in the backend by the AWS. So it's just a plug and play kind of service, you can say. and also it's highly available and durable. So Amazon EFS offers two file system types that you can choose from based on your durability and availability needs. EFS regional file systems, which is recommended by AWS, offers the highest levels of durability and availability by storing data with and across multiple availability zones. EFS one zone file systems store data redundantly within a single AZ, so data in these file systems will be unavailable and might be lost during a disaster or other fault within the availability zone. So it is designed for the 99.11 times 9 total of durability. So Amazon EFS storage classes over a given year. Also, EFS file system data is accessed using AZ specific EFS mount targets, which are designed to be highly available within an availability zone. So EFS regional file systems support concurrent access from EFS mount targets in all availability zones in the region where they are located. That means you can architect your application to failure from one availability zone to other availability zones in the region to achieve the highest level of application availability. So EFS one zone file system support only one high available EFS mount target in a single availability zone, which means data may become unavailable during a disaster or other fault within that availability zone. Also, it is fully elastic and highly scalable. By default, Amazon EFS file system storage and throughput capacity is elastic, growing and shrinking automatically to suit your workload needs. So with elastic capacity, provisioning is unnecessary and you are built only for what you use. So Amazon EFS file systems can deliver the throughput, IOPS, and low latency necessary for a broad range of workloads independent of the file system size. So Amazon EFS is designed to be highly scalable, growing to petabytes of storage, hundreds of thousands of IO operations per second, and tens of gigabytes per second of throughput with massively parallel access from various AWS compute instances. So it has the you can say in general the elasticity and scalable features according to the pay as you go model. So the pricing is also pay as you go since it's the core of the AWS cloud. So there are some storage classes. So Amazon EFS offers three storage classes here. First is the EFS standard, second is the EFS infrequent access, and EFS archive. So data that is frequently accessed tends to have higher performance needs. So EFS provides an SSD powered EFS standard class designed to deliver sub-millisecond latencies. So we can see that compared to HDD, SSD is a superior storage class which involves which has a higher IOPS and throughput performance. So continuing, for data that's infrequently accessed, you can use EFS two cost optimized storage classes that provide low double digit millisecond latencies. So latency is also taken care of with very low figures. EFS infrequent access, in short I, designed for data accessed only a few times a quarter, and EFS archive designed for data accessed less than few times a year. So EFS I, which is infrequent access, offers up to 95% lower cost than EFS standard for infrequently accessed data. So again, because the accessibility feature is a cost determiner here, since if you are not accessing that data like regularly, then obviously you'll get a lower cost. So EFS archive is a further cost optimized experience for colder data. Colder data means which is data stored for a very long period of time compared to the these I options we have, offering up to 50% lower cost than EFS infrequent access. So this is about the storage classes. Next is the shared file system with NFS version 4 and version 4.1 support. So Amazon EFS provides secure access for thousands of connections for Amazon Elastic Compute Cloud, which is EC2 instances as well as AWS container and serverless compute services. So Amazon EFS also simultaneously supports on-premise servers, which means private data center servers, using a traditional file permissions model, file locking, and hierarchical directory structure through the NFS v4 protocol. So Amazon EC2 instances can access your file system across availability zones and regions, while on-premises servers can access it via AWS Direct Connect or AWS VPN services. You may be having doubts what is the NFS protocol here. So network file system is a distributed file system protocol that allows the user on a client computer to access files over a network in a manner similar to how local storage is accessed. So NFS versions 4 and 4.1 here bring several enhancements and improvements over earlier versions. So the first one is the session based communication. So NFS v4 introduces the concept of sessions, establishing a persistent communication channel between the client and the server. So this enhances performance by reducing the need to re-establish connections for each request. Also, it introduces a stronger security. So there are some improved security mechanisms enabling the use of stronger authentication mechanisms like Kerberos. It also supports the IPv6 protocol. So it also introduced the stateful operations as well. So that meaning that the server maintains information about the state of the client's file system. So this helps in managing client server interactions more efficiently. Also we have in NFS v 4.1 we have this parallel NFS. So it was a significant enhancement that allowed for parallel data access by enabling clients to directly access storage devices, distributing workload and improving performance. So these are session based communication protocols which have improved security, introduction of PNFS for parallel access, separation of metadata and data operations. So these are for distributed file system environments, making them suitable for wide range of applications and network configurations. So this was about the shared file system. So it also has support for containers and serverless file storage. So in addition to traditional EC2 instances, Amazon EFS runs on containers and serverless compute service. So containers you mean ECS, EKS, which are Kubernetes based services. Serverless we have the Lambda that require shared storage for latency sensitive and IOPS heavy workloads at any scale. In a single step, Amazon EFS provides applications running on Amazon Elastic Container Service, Amazon EKS, AWS Fargate, AWS Lambda with access to shared file systems for stateful workloads. Stateful workloads means where the application should be persisted. So security and compliance. Control network access to your file systems using Amazon Virtual Private Cloud, security group rules, and application access to your file systems using AWS IAM policies and Amazon EFS access points. So AWS is certified under numerous certification programs to help you achieve your compliance goals. So compliance is a very important aspect for some customers and organizations because they need to have the data for a specific time period to adhere to the respective country's policies. So AWS is already certified. It has tied up with various government policies and compliances across the world. Like we have the payment data industry PCI standard. So like it's an example, but EFS is also you can say that it is compliant with respect to the world security standards. Next is the data transfer. So we have the AWS data sync, which is a managed data transfer that makes it faster and simpler to move data between on-premise storage and Amazon EFS. So you can use data sync to transfer active datasets over the internet or AWS Direct Connect up to 10 times faster than open source tools without the need to modify your applications. So we can use the service for one-time data migrations, ongoing workflows with periodic synchronization, or replication for data protection and recovery. So data sync automatically manages many tasks known to slow down migrations or burden IT operations, including the infrastructure management, encryption, data validation, and data transfer orchestration. So we have this AWS transfer family, which provides fully managed support for all the operations for file transfers directly into and out of Amazon EFS, with support for SFTP, file transfer protocol, or SSL, which is FTPS, FTP. These are like legacy transfer protocols. So transfer family helps you seamlessly migrate your file transfer workflows to AWS. So this was about the theoretical concepts of AWS, EBS and EFS. So let's directly jump into the hands-on sessions. The AWS console currently, and we'll initially create a EC2 instance. So I'll go to EC2. I'll hit launch an EC2 instance here. So as it is how we saw in the EC2 section, we'll accordingly put all the details here. Internship server. Let's ignore the tags for now, or we can add it. We can. It's always a best practice. I keep on saying. So we can say created by. Internship studio. Yep. I'll use the default Amazon Linux again here, which is free tier eligible. So I'll go ahead and again select the T2 micro, which is the free tier eligible, has the instance type. So again I'll be going to be using my standard key pair, which is already created, and here I will select an existing security group which we had created previously. So this is the launch wizard one which we had created in the previous session. So coming to the storage here, so here is one. Actually we are going to configure the EBS here. What I'll go is, we already have this pre-existing one which is 1 into 8 GB GP3 volume, but here we'll go ahead and create a new volume. I'll hit add new volume, and the type here is, we have this various types. We have general purpose, we have general purpose SSD GP2, provisioned IOPS SSD, we have provisioned IOPS SSD IO2, cold HDD. So I'll just select a magnetic standard here. So this is the overall like simple selection, but when you go to the advanced here, we can fine tune the custom volume type here. So we have the size, we have the delete on termination option, we have the device name which is required. So we have the volume type, we can select as standard. We have encryption, so currently we have not, we'll select the not encrypted option. So we have the snapshot option, we have the IOPS. So what this delete on termination does is, if I delete the EC2 instance, then if we want the EBS volume to exist or not. So if I type S, then that will exist. It will delete the EBS volume. If I type, like if I select the no option, then the EBS volume will stay. So yeah, this is pretty much what's needed. So I'll go ahead and launch this instance with the two volumes attached. So it says successfully initiated the launch of instance. We'll quickly go to the instance dashboard. It says it's in the pending state. We'll wait for it to become success. So keep hitting refresh. So we can see now that the instance state is running. So we'll select the instance here. So if you are dealing with the EBS volumes here, it will be visible under the storage section. So we have the status here, we have the two volumes. So you can see the attachment status as attached. So they are successfully attached to our EC2 instance here under the block devices section. And one more section where we can see the volumes here is in the left side. We have the elastic block store section, and go to volumes here. And here are the two volumes which are readily available for us. So for now we have not involved encryption, so these are not encrypted currently at the moment. So you can see the available volumes here as well. What we'll do is we'll just click on the volume, and we can see a whole lot of information here as well. So it says volume state, in use, we have encryption, fast snapshot restored is no, multi-attach enabled no. So couple of information about the respective volume as well. So we'll go and uncheck that again. So what we'll do here is we'll just modify this volume on the fly. It's already being in use. So under actions, we'll hit modify volume. So we have this volume ID here. So we'll change the type of volume to general purpose SSD GP3. So I'll hit GP3. We have a couple of information as we already saw in the theoretical sessions. We can modify the GB. Minimum is the 1 GB, maximum is the 16,384 GB. And we have the IOPS. So minimum is the 3000, so maximum is the 16,000 IOPS. So the throughput also is the minimum 125 MIB. Also we can increase up to the 1000. So I'll modify it on the fly. So it gives sort of a warning, like if you are increasing the size of the volume, you must extend the file system to the new size of volume. So you can currently ignore for now. So I'll click modify. So it says the volume is being modified. So I'll just click and hit refresh. It still says the volume is being modified. I think it may take some time. We'll hit refresh couple of times. Yeah, we can see that the type is GP3 here. It got changed from standard to GP3. So it's almost instantaneous here. But for some reason, I think it says it's still being monitored. So we'll cancel that. So we'll do one more operation here. So what we'll do is we'll just select this volume and we'll detach from the EC2 instance. We have under actions here. We'll go ahead and detach volume. So we'll go ahead and detach. So it says unable to detach root volume. So I think root volume will need to persist, so we'll go ahead and detach the modified volume here. So I'll go ahead and detach the modified volume. So it says successfully detached volume, but we'll keep refreshing. It will take some time actually. So we'll keep hitting refresh until the upper one disappears. So you can also see that the volume is detached under the instances. So if you go to the instances section, so under storage you can see there is only one EBS volume that is attached, which is the root volume. So another operation that we can perform is under volumes we can go and delete the volume itself. So what I'll do is I'll just select it, and under actions just have delete volume. It says successfully deleted volume, so the operation is almost instantaneous. So you have only one volume, which is the root volume now. So also during the exams, there's one question that is asked fairly like many times, which is like how we migrate one EC2 instance from one region to another region. So we have this root volume, right? So the root volume is where the operating system of the EC2 is installed actually. So we'll do an operation. So we'll select here. So you can see also see that attached instances is there, which is our internship studio. We'll just drag it. So this is the server name that we have, which is the internship studio server. So I'll select this, and under actions we have this option as create a snapshot. So snapshot is nothing but like a photograph. So it's like a photograph of the root device volume at that point of time, you can say. So we'll name this snapshot. I'll see internship. You can create any name, just like I'm keeping consistency here. Studio snapshot, and then we'll ignore all these things. I'll go ahead and create a snapshot, and we can see that it has successfully created snapshot from volume, which is our root volume, you can say. So it also says that if you need a snapshot to be immediately available, we can consider another option called the fast snapshot restore. So now we'll go to the snapshot section under the Elastic Block Store. We'll go to snapshots, and we can see the snapshot has populated here. So it has all the details. It says snapshot status is completed, progress is available. So it is to use for our EC2 instance for the deployment of the instance to a different region. So now we'll implement a different region EC2 deployment using this snapshot. What I will do is I'll just select this snapshot, and under the actions I'll just hit copy the snapshot. So we'll have this prompt saying to fill like some details. So what I'll do is we'll change the destination region. So I'll go to EU West 1, which is European West 1. So we'll not encrypt the snapshot, we'll keep it as it is, and I'll just hit copy snapshot. So it says successfully created snapshot copy. So respectively you'll go to the region which is US West 1. Sorry, we have selected EU West 1. Uh, EU, yeah, Europe, Ireland. So each time you change the region, the console will automatically update to that concurrent region. So you can see the snapshot status is still pending. So we need to wait couple of minutes, I think, for it to have the available status. So after around 2 or 3 minutes, we can see that the snapshot is successfully copied to the Ireland region, which is EU West 1. So now what we'll do is we'll create an image from the snapshot here. So we'll just select here, create image from snapshot. So I'll just say internship image. So we'll leave, I think, rest all of them as default. I'll just go ahead and create the image. So it says successfully requested new image, which says AMI hyphen a special characters, which is unique. So it says the image is being created. The image creation process can take several minutes to complete. So that we can see under the AMIs. Under the images in the left hand side we have this. So it says it's immediately available, so we have created a fresh image. So now from here the you can select the under images we have the AMI, so you can select the respected image and we can launch instance from the AMI. But we'll not be doing here, I'll not be going ahead and launching a instance again, but because you know the steps already, so to avoid unnecessary wastage of server time here, so we'll just ignore that step. It's just straightforward. So we need to remember that it's very important. So it's possible, like from a snapshot from another region, we can copy that snapshot and select a different region somewhere else from the original region, and then we can go ahead and launch an EC2 instance from that region. So yeah, this was all about our EBS volumes related operations that we had till now. So I'll again go ahead and reiterate the different tips for EBS volumes regarding the exam point of view. So what we do is actually volumes exist on EBS whereas snapshots exist on S3. So whatever the snapshot we created, they have their uh, they persist towards the S3 storage. And snapshots are nothing but the point in time photographs of volumes, and they are incremental in nature. So the first snapshot will take some time to create, but for the consistent snapshots we need to stop the instance and detach the volume. So we can also share the snapshots between AWS accounts as well as between regions, but first you need to copy that snapshot to the target region. So as we did here to the Ireland region from the North Virginia region, you need to share the snapshots to a similar way. Also we saw that we can resize the snapshots, we can resize the EBS volumes on the fly as well as changing the volume types while the instance is already while the EBS volume is already attached to the instance. So there were the couple of points that we need to keep in mind. So we'll do one more operation here called the EC2 hibernation. So what happens in a EC2 hibernation? So when you hibernate an EC2 instance, the operating system is told to perform hibernation, which means suspend to disk. So hibernation saves the contents from the instance memory, which is RAM, to our Amazon EBS root volume. So we persist the instance Amazon EBS root volume and any attached EBS data volumes here. So what we need to do is we need to do here the selection of instance here, and we have to go ahead and we have the option of we'll stop the instance here first. So we have successfully stopped the instance. So it will take some time. We can see that while launching the instance itself, we have enabled like stop hibernate behavior as disabled. So if we had enabled, then there was a chance that we could see the hibernation, but make sure that before starting the instance, you have this as enabled. That's it for this session. There are some important points that you need to know about EC2 hibernation. So EC2 hibernation preserves the in-memory RAM on persistent storage, that is EBS. So it helps us to faster the boot up process because you do not need to reload the operating system again. The instance RAM must be less than the 150 GB. So instance families include instances in the general purpose compute, memory and storage optimized groups. So this feature is available for Windows, Amazon Linux, AMIs and Ubuntu. So instances can't be hibernated for more than 60 days. So it's also available for on-demand instances and reserved instances. So we'll try to create a elastic file system EFS as well. So I'll quickly type EFS, which is the managed file storage for EC2. So this is the console UI of that. So it now offers, it is saying it is Amazon have introduced a new Amazon EFS archive here, which now offers a new archive storage class. It's a new launch, I guess. So for now I'll just create a file system here. So I'll just type internship studio EFS. So I'll use the default VPC. It says it was rejected because the specified KMS keys could not be created. So let me. So I'll bit customize the steps here. Yeah, finally it's created. So it's encrypted by default. So there's no size as well. So the default size is 6 KB. So it will grow as we build on it further. So we have some other service such as AWS backup as well. So we can use AWS backup to backup AWS services. So we have, I'll just give an overview there. Let's backup. Yeah. So this is a service to help us uh, backup the services such as EC2, EBS, EFS, for example. Uh, we can use AWS organizations here in conjunction with AWS backup to backup different AWS services. So we have the support set services which have Amazon EBS, EC2, RDS, DynamoDB, EFS, and One benefit is backup gives you the centralized control here, so it lets us automate the backups and define lifecycle policies for our data. So you can get better compliance as you can enforce your backup policies, ensure your backups are encrypted, and audit them once complete. So this is it for our session now, and this is also like we have this dashboard as well. We have the jobs dashboard and some sort of it. We are not going deep, just I'm giving overview of that this service exists here. So going back to our slide, yeah, that was it. And I think hope you had a good hands-on session and a theoretical session as well. So we discussed these concepts today. So we discussed what AWS, EBS and EFS were. So we also discussed the overview, the features and types of EBS and EFS. We also did the hands-on session on volumes and snapshots, taking a snapshot and launching a EC2 server in a different region. We also explored on EC2 hibernation, and we also explored on how to create a EFS. And also we discussed about sample concept on AWS backup as well. So hope you had a productive session. So in the next session, we'll be discussing on the AWS databases. We have the RDS, Aurora, and DynamoDB. Thanks for attending the session, and see you all in the next session. Bye.